Hello students, welcome to the channel SNW Physics Classes. If you really understand the concepts taught here, please turn the black thumb rule. That means like the video, share with your friends and subscribe to the channel SNW Physics Classes. Do not forget to hit the bell icon for the latest updates. This is the series of VERMA solution and we are going to solve numerical problems of last chapter of class 9 physics, that is sound. And in this video, we are going to deal question number 1 to 6. Question number 1. Find the frequency of a wave whose time period is 0.002 seconds. ठीक है, यहाँ पे हम लोगों को frequency find out करनी है और time period दिया हुआ है question में. Let us see the solution. Here the time period of the wave t is equal to 0.002 seconds. Now we know the formula of frequency. Frequency is equal to 1 by time period. We will divide this time period by 1. Okay, 1 divided by 0.002. So the frequency we get is 500 hertz. Thus the frequency of the wave is 500 hertz. Question number 2. Find the time period of source of sound wave whose frequency is 400 hertz. Okay, previous question में time period दिया था और हम लोगों को frequency find out करनी थी, but ये question जो है just उसका reverse है. यहाँ पे frequency दिया है और हम लोगों को time period find out करना है. So given that frequency is 400 hertz, time period is equal to 1 by frequency. So 1 by 400, that is equal to 0.0025 seconds. Thus the time period of the sound wave is 0.0025 seconds. Question number 3. A sound wave causes the density of air at a place to oscillate 1200 times in 2 minutes. ठीक है, यहाँ oscillation जो है 1200 times जो है वो 2 मिनट के लिए हो रही है oscillation. Now find the time period and frequency of the wave. ठीक है, 1200 जो oscillation हो रही है वो 2 मिनट में हो रही है. Now let us see the solution. Number of oscillation is 1200, time taken is 2 minutes. ठीक है, time जो है 2 मिनट लग रहा है. तो to find out the time period, we will divide the time taken by number of oscillation. So time taken is 120 divided by 1200. ठीक है, zeros are cancelled here. So we will get the time period which is equal to 0.1 second. To find out the frequency, we will use the formula 1 by time period, and 1 by 0.1 is equal to 10 hertz. Thus the frequency of the sound wave is 10 hertz. Question number 4. A source produces 15 crests and 15 troughs in 3 seconds. ठीक है, crest क्या होता है? ये upper वाला जो हमारा wave का part है that is crest, और जो lower depression है that is called trough. तो 15 crest और 15 trough जो है वो 3 सेकंड में बन रहा है. When the second crest is produced, the first is 2 centimeter away. अब ये बोल रहा है कि दो crest के बीच का difference जो है that is 2 centimeter away. We have to calculate the wavelength, the frequency and the wave speed. So the solution here is time period is equal to, we know that 1 by frequency, wavelength is equal to 2 centimeter, क्योंकि यहाँ पे बोल रहा है कि first और second जो crest है उन दोनों के बीच का जो distance है that is 2 centimeter. और we know that the distance between the two crest or two trough is called wavelength. ठीक है, दोनों crests के बीच के का difference को हम लोग बोलते हैं wavelength. तो यहाँ पे wavelength already question में दिया हुआ है that is 2 centimeter. हम लोग को सिर्फ identify करना है according to the question. Number of waves produced per second. एक सेकेंड में कितना वेव्स बन रहा है? तो 15 ट्रॉप और 15 क्रेस्ट बन रहा है 3 सेकेंड्स में. तो 3 को हम लोग डिवाइड कर देंगे 15 डिवाइडेड बाय 3. तो नंबर ऑफ वेव्स एक सेकेंड में कितने बन रहे हैं? 5 वेव्स बन रहे हैं. सो द फ्रीक्वेंसी इज द नंबर ऑफ ऑसिलेशन पर सेकेंड. ठीक है, हम लोग फ्रीक्वेंसी को डिफाइन करते हैं नंबर ऑफ ऑसिलेशन पर सेकेंड. सो फ्रीक्वेंसी इज इक्वल टू 5 hertz. Now the speed of wave is equal to frequency into wavelength. Do you know this formula? Speed is equal to frequency into wavelength, that is denoted by nu and lambda. So frequency is 5 hertz and lambda means the wavelength is 2 centimeter. So the speed of wave is 10 centimeter per second. Question number 5. A sound wave travels at a speed of 340 meter per second. एक sound wave है, इसकी speed है 340 meter per second. If its wavelength is 2 centimeter, अगर इसका wavelength जो है 2 centimeter है what is the frequency of the wave, what will it be in the audible range. ठीक है, यहाँ पे दो क्वेश्चन पूछ रहा है कि साउंड वेव है वो ट्रैवल कर रहा है 340 मीटर पर सेकंड की स्पीड से और उसकी वेवलेंथ जो है वो 2 सेंटीमीटर है, तो हम लोगों को फाइंड आउट करनी है फ्रीक्वेंसी ऑफ द वेव और क्या ये फ्रीक्वेंसी जो है ऑडिबल रेंज के अंदर होगी या नहीं होगी. लेट अस सी द सॉल्यूशन. गिवन दैट वेलोसिटी ऑफ साउंड मींस द स्पीड ऑफ साउंड इज 340 meter per second, wavelength is 2 centimeter, we will convert it into meter, 0.02 meter. Now we have to find out the frequency. According to this formula, speed is equal to frequency into wavelength. We will put all the values here. ठीक है, यहाँ पे speed कितना दिया हुआ है, that is 240 meter per second. We have to find out the frequency and wavelength is 0.02 meter. So the frequency is equal to 340 by 0.02 meter, that is 17,000 hertz. And we know that the audible range is between 20 hertz to 20,000 hertz. ठीक है, audible range के बारे में हम लोग जानते हैं कि 20 hertz से 20,000 hertz तक होता है और यहाँ पे हमारी जो frequency आ रही है that is 17,000 hertz. So this sound wave is at audible range. ठीक है, इस sound को हम लोग सुन सकते हैं, it is under audible range. Question number 6. Given that sound travel in air at 340 meter per second, find the wavelength of the wave in air produced by 20 kilohertz sound source. ठीक है, यहाँ पे कह रहा है 20 kilohertz sound का एक source है और sound का जो speed है air में that is 340 meter per second. This is the first part of the question. ठीक है, पहले इसका solution हम लोग देख लेते हैं. Given that in air velocity of sound is 340 meter per second, frequency is 20,000 hertz, so we have to find out the wavelength. Formula हम लोग वही use करेंगे. Speed of sound is equal to frequency into lambda. So lambda is equal to speed of sound divided by frequency. Speed of sound is 340, frequency is 20,000 hertz. ठीक है, इसको कैलकुलेट करने के बाद हम लोगों को मिलेगा 0.017 मीटर और अगर इसको हम लोग सेंटीमीटर में कन्वर्ट करते हैं that is 1.7 सेंटीमीटर. ये तो हो गया फर्स्ट पार्ट ऑफ द क्वेश्चन. Now again the question is saying that if the same source is put in water tank, ठीक है, अगर उसी sound source को हम लोग water tank में रख देते हैं, what would be the wavelength of the sound wave in water? ठीक है, अब उस source को हम लोगों ने water में रख दिया, अब उसका जो wavelength है water में क्या होगा if the speed of sound in water is 1480 meter per second. ठीक है, same formula we will use given that in water speed of sound is 1480 meter per second and frequency is again क्योंकि source हम लोगों ने same लिया है that is 20,000 hertz का source है, so wavelength is equal to speed of sound divided by frequency. Speed of sound is 1480 divided by 20,000, we will get 0.074 meter, which is also equal to 10.4 centimeter. If you have any problem, any confusion in any of the calculation of this video, please comment in the comment section, like, share and subscribe to my channel. Thank you very much for watching.